Alright, today our notes is on 9-1, which is graphing quadratic functions. The objective or objectives for today are to be able to analyze the characteristics of graphs of quadratic functions and to actually be able to graph quadratic functions. So let's go ahead and get started. First of all, you need to know that quadratic functions can be written in the form f of x equals ax squared plus bx plus c, where a cannot be 0. Because if a was 0, then we wouldn't have an x squared. And we know that quadratic functions means that you've got an x squared. And we understand that this f of x right here, all that means is the same thing as saying y. So on our examples today, you will see instead of f of x, you will see y equals, but understand that it could be f of x at any time. All right, we understand that the parent function is f of x equals x squared. And we actually have that graphed over here on the right side. Right here is the graph of the parent function. Not the best of that, but there it is. And standard form means that it's ax squared plus bx plus c. We know that the type of graph, we call that a parabola. It's nonlinear. It is a parabola. Axis of symmetry. The axis of symmetry, here's our new formula, so definitely make sure you're copying this down. It's x equals the opposite of b divided by 2a. And the axis of symmetry, that is the line that cuts through the parabola to make it symmetric. So right here I'm drawing the axis of symmetry for this one. It cuts it right down in the middle. And our y-intercept is, that point is 0c. And the c that we're talking about is this c right here. So if it's in the standard form, you should know what the y-intercept is. It will be that c value. So let's look at these characteristics a little bit more. And right here, we're going to determine minimum or maximum. So this is all new stuff that we're learning here, minimum and maximum. Minimum means that you've got a minimum point, the lowest point. Maximum means you've got a highest point. So looking at this first graph here, do we have a lowest point? Well, we see that the arrows keep going down. Keeps going down. So this graph, this parabola, goes down to negative infinity. So there is not a minimum point. Do we have a maximum point? Yes, that's the highest point on this graph. So right here, we see the highest point on the graph is 2, 1. So this has a maximum. Okay, let's look at the next graph here. Notice that the arrows keep going up. So that means the highest point on this graph would be infinity. So we do not have a maximum. But if we look right here, the lowest point is right there, and that point is 1, -4. And that is our minimum point. Okay, notice that the maximum and the minimum is always at the vertex. So it's always the vertex. Okay, now notice we've got two parabolas, one's going down and one's going up. Let's think, what would cause the parabola to go up or down? Well, remember our standard form. Standard form is y equals ax squared plus bx plus c. And if the a is negative, the parabola is going down. And if it's going down, you've got a maximum point. Okay, if we've got y equals ax squared plus bx plus c, and the a is positive, that means your parabola is going up. Therefore, you've got a minimum point. So A is positive, the parabola is going up, you've got a minimum point. That minimum point is at the vertex. If the A is negative, the parabola is going down, you've got a maximum point at the vertex. Okay, let's look at example 1. So, right here they want us to graph. They want us to find the vertex, the axis of symmetry, and the y-intercept, state the domain and range, and determine whether the function has a maximum or a minimum value. So let's first do the easy part right here. Determine if it has a maximum or a minimum. Well, let's look at this A value. The A value here is positive. Therefore, we know that the parabola is going up, and if it is going up, we know that it has a minimum point. Okay, so we've got that situated. Okay, now let's find the vertex. Okay, in order to find the vertex, we're going to do x equals the opposite of b over 2a. Okay, so the b here is 4, so I'm going to do the opposite of that, which is negative 4 over 2 times our a value is 2. So that gives us negative 4 over 4, and that gives us negative 1. All right, so now I'm going to make an XY table, and I'm putting this negative 1 right in the middle of it. So that means I'm going to put negative 2, negative 3 above it, and 0, 1 below it. Okay, so now we're going to plug in this negative 1 into the x values to figure out what y equals. So when we plug in negative 1, we're going to do 2 times negative 1 squared plus 4 times negative 1 minus 3. Well, negative 1 squared is 1. 1 times 2 is 2. 4 times negative 1 is negative 4. And then minus 3. So I've got 2 minus 4. That is negative 2. Negative 2 minus 3 gives us negative 5. So whenever I plug in negative 1, I get negative 5. Now let's go ahead and plug in 0. When you plug in 0, remember, you get the c value, because 0 squared is 0, 2 times 0 is 0, 0 plus 0 is 0, minus 3, and there's our c value, negative 3. All right, and now let's plug in the 1. So we've got 2 times 1 squared plus 4 times 1 minus 3. So that gives us 1 squared is 1 times 2 plus 4 minus 3. So 2 plus 4 gives me 6. 6 minus 3 is 3. All right, now this XY table is symmetrical. So right here I got negative 5, negative 3, and 3. Well, the negative 3 is going to match up with the negative 2, and the 3, the very last one, is going to be the top one. And now we plot those points. Negative 3, 3. Negative 2, negative 3. Negative 1, negative 5. And hopefully your parabola looks more like that U shape than mine does. Okay, so now, right here, let's get some key points. right here in the middle of our XY table, that right there is our vertex. So the vertex is -1, -5. The next one that we need to figure out, the axis of symmetry. The axis of symmetry is going to always be x equals the first number in your vertex, x equals -1. Because what we can do here, and you will be doing this, is you'll be drawing that axis of symmetry, and notice how it cuts through that parabola at -1. And the equation of that line is x equals -1. The y-intercept. The y-intercept here is 0, -3. And the domain and range. The domain here will be all real numbers. And then the range would be, well, let's see, we got to start from the bottom up. So the lowest point here is -1, -5. I'm sorry, scratch that. Okay, the lowest y value, because remember the range is our y value, the lowest y value is -5, and then all the way to infinity. So it would be y is greater than or equal to -5. If you wanted to write that as like we do in Algebra 2, it would be bracket -5 to infinity, and then parentheses. So we've stated the domain, the range, we did the vertex, the axis of symmetry, the y-intercept. We stated that it was a minimum right here. And the minimum value for this would be -5. Okay, that's the lowest y value is -5. All right, let's look at another example. Example 2 here. So we're doing the same thing. So let's first do the maximum or minimum. So right here, because this is negative, our a is negative, it's going to go down. Therefore, we have a maximum value. Okay, so now let's do x equals the opposite of b over 2a. So our b here is 6, so I'm going to do -6 over 2 times -3. So it gives us -6 over -6, which equals 1. So now I'm going to do an xy chart. The 1 is going to go in the middle. I've got 0, -1 above it, 2, 3 below it. So now let's go ahead and plug in that 1. So -3 times 1 squared plus 6 times 1 minus 4. So this gives us -3 plus 6 minus 4. That gives us 3 minus 4. That gives us -1. So right there, that gives us -1. Now I can either choose 0 or 2, and I'm going to get the same answer, either one that you pick. Now 0 is an easy number to plug in, because I know if I plug in 0, I'm going to get the c value, which is -4. So I know whenever I do 2, I also get -4. Okay, now you can plug in -1 or 3, doesn't matter which one, you're going to get the same answer. I'm going to choose 3 just because it's not negative. So let's see here, -3 times 3 squared plus 6 times 3 minus 4. So right here we get 3 squared is 9. 9 times -3 is -27 plus 18 minus 4. -27 plus 18 gives me -9. -9 minus 4 gives us -13. So I know that this will be -13, and this one right here will be negative 13. All right, so now let's go ahead and graph. We've got 1, negative 1, 2, negative 4, and 0, negative 4. And then negative 13, that goes off of my graph. So we're just going to connect these, and we know that it's going to keep going down there. Okay, so now let's label all of our different parts here. Okay, so they wanted to know what the vertex is. The vertex, remember, is that middle part of our xy, and that is 1, negative 1. Or you can find it on your graph, 1, negative 1. The axis of symmetry is x equals 1. Remember, it's going to be that first, the x number of your vertex. And remember, we can also going to draw that line there, x equals 1. And that axis of symmetry cuts the parabola in half. The y-intercept, that is 0, and then your c value, which was negative 4. The domain here, domain's always going to be all real numbers. The range here is, notice that now instead of y is greater than or equal to, all of the values are lower than negative 1. So it's going to be y is less than or equal to negative 1. If you wanted to do that algebra 2 style, it would be negative infinity to negative 1 with the bracket there. And to determine whether it was a maximum or a minimum, we already said we had a maximum, and that maximum value was negative 1. And there it is. Let's look at example 3. Okay, find the vertex, the axis of symmetry, the y-intercept, state the domain and range, and determine if it has a maximum or minimum. Well, let's first look here, and because our a, the number in front of the x squared, is positive, it's a positive 1, that means our parabola is going to be going up. Because it is going up, it's going to have a minimum value. Okay. Let's go ahead and start. So x equals the opposite of b over 2a. Well, notice right here we are missing that b value. All we have here is the a and the c. So if we don't have a b value, that's going to be 0. 0 divided by 2 times 1. Well, 0 divided by 2 gives you 0. So in your xy table, 0 is going to be in the middle. Negative 1, negative 2, and 1, 2. All right, so now we know that whenever we plug in 0, we get that c value, so that's going to be negative 4 there. Now let's go ahead and plug in 1. 1 squared minus 4. Well, 1 minus 4 gives us negative 3. So I know that this is going to be negative 3, and the negative 1 is going to be negative 3. Now let's plug in 2. 2 squared minus 4. That gives me 4 minus 4, and that is 0. Okay, so now let's go ahead and plot these points. Negative 2, 0. Negative 1, negative 3. 0, negative 4. 1, negative 3, and 2, 0. Connect those points. And there's our parabola. And it's going up just like we said it would. So let's look for these parts. The vertex. The vertex here, right here in the middle of our xy table, it is 0, negative 4. The axis of symmetry. The axis of symmetry, notice that it's cutting right down in the middle, and that is x equals 0. The y-intercept, is the same as the vertex. That's going to be 0, -4. And then we state the domain and the range. Remember I said the domain is always all real numbers. And then the range, well, let's look here. The lowest point is -4, and then it goes all the way up. So that means y is greater than or equal to -4, or Algebra 2 style would be -4 all the way to infinity. And we've already said it had a minimum value. That minimum value was -4. All right, let's look at one more example.